So, here comes some notes. Let's see. This week, we're going to do complete the square, and then we're going to take a look at factoring versus completing the square. We review. Then Thursday is the take-home test, and Friday is the test. Sound good? I will probably give you the take-home test though on Wednesday. Just don't tell the other Algebra 1 classes because they might get all jealous and say, all right, Sophia? So, you happy? All right, so we're going to start solving by completing the square. And completing the square is the most widely accepted way of working these problems. Though it's a little bit more complex, but people make it complex because they don't follow the rules for it. So let's just walk through. So they want us to factor all three of the quadratics. So is this one that I could do the quicker way? If so, why can I do it the quicker way? My lead coefficient is just a 1, so I might be able to get away with saying x minus 2. Nope, I take that back. X minus 5 and x minus 1. If I multiply that whole thing together, I get x squared minus 6x plus 5. And then because it has an equal sign, we set each of our polynomials equal to 0. Okay, so we can do them our quicker way. And of course, if you don't remember the quick way, then on this one, you could probably do the other way, saying, okay, our magic number is negative 24. What numbers add up to give me negative 5 of that? And it would be 8 and 3. I'd have a negative 8 to positive 3. And then just plug in your values. Group them. That's 3. That's going to give me x minus 4 and 2x plus 3. But I'm not done yet. What do I have to do still? Yeah, set them both equal to 0. So this will solve pretty quickly, give me just x equals 4. And this will give me 2x equals negative 3. And then x equals negative 3 over 2. Okay? And again, sometimes you might be able to quick factor it. Okay, there's ways, sometimes if you factor enough, you can start seeing the patterns, even if your lead coefficient is something other than 1, like on that first one. And then number 3, in order for us to factor it, we need to bring the 1 over. Is that okay so far? I can't do the factors in my head, so I'm going to go, okay, I want the factors to be 8. What factors of 8 add up to 6? 2 and 6. All right, 2 and 4, excuse me. If I add 2 and 4 together, I get positive 6. If I multiply them together, I get positive 8. So I get 8x squared plus 4x plus 2x plus 1. Factor that out. So I get 4x, and that's 2x plus 1. There's nothing to factor out. You factor a 1 out. And then I get 2x plus 1 and 4x plus 1. Set those both equal to 0 because it was equal to 0. So I get 2x equals negative 1. X equals negative half. There's one solution. And this is going to give me 4x. That's a 4, at least trying to be. Equals negative 1. So x equals negative 1/4. Okay, so all things that we've done before. Now, are you staying up on it? I don't know. Probably makes you pretty unusual of a student if you go home and you're reviewing past stuff. But hopefully you see the repetition over and over again so you have the basic idea of the routine to solve it. Okay? Any questions on these 3? Yeah?
What are the x's in the limit?
I have x equals negative 1/2 and x equals negative 1/4. Sorry about that. Yeah.
Okay, so on the
Third one, right one.
the very top where it says positive 4 plus 2, how does that go into 8?
Okay, so remember, so that's where it's starting to bother you in the head. Okay, remember you take the last term times the first term. So 4 times 2 gives me 8. 4 plus 2 gives me 6.
Oh, okay.
Got it? Good questions. May I move on? All right, so things that we might remember with completing the square. So be sure your a value is equal to 1. If it's not, divide everything by a. Then there's another step where you make a space. Between the x term and the constant. Be sure to add new value to both sides. So that's just some of the steps. It's not all of them, but maybe we'll see when we can generate them. Can I move on? Cool. All right, let's see if we can figure out some of our steps. Okay. Example number 1. I have x squared plus 14x plus 2. Let me do this. Dang it. Okay. So I'm not solving for it. I just want to complete the square. And remember, if I complete the square, it puts it in something called vertex form, right? And if I don't have an equal sign, I have to add and subtract it from the same side. So my lead coefficient is a 1, so I don't have to do anything that. My next step is make a space. Is that okay? The big non-mathematical term. All right, ready? I want half of that and then square it. So what's half of 14? 7. What's 7 squared? 49. If I add 49, I also have to subtract 49. Okay? So this right here is what you call a perfect square trinomial. What that means is if I take the exact same binomial and multiply it times itself, FOIL it out, I'd get that. So let's figure out what this binomial would be. It's going to be x plus, there's a plus sign there. What was half of that? 7 squared. And then look at this. I added and subtracted it from the same side. Why did I have to add and subtract it? If I add something
to one side, to the other.
Yeah, kind of, because we don't have an equal sign, so you have to do the opposite operation. So I can't just add 49 to something saying, hey, look, it's the same. It's like I have it and I have it. And remember I gave you the terminology, it's like daylight saving time, where we cut an hour off at the end of the day and put it at the beginning of the day to act like we have a longer day. No, the sun's up for the same amount of time. It's just we've adjusted our clocks. So I have this little piece of arithmetic to worry about right here. So what does that equal if I add or subtract it? Negative 47. So this is called the vertex form. If we were graphing this parabola, that's how you would have it. And it's always going to be that same routine. Okay? Example number 2. Is my a value equal to 1? No, what is it? 2. So what I'm going to do is I'm actually going to go, well, I'll divide that by 2, divide that by 2, divide that by 2, so I get this. And I'll make a space all in one. Is that okay? Cool. All right. X minus half of this, 3, square that, becomes plus 9. If I add 9, what also do I do with it? Subtract. Yeah. All right, so I'm going to do this math. 13 over 2, that's 6.5, right? 6.5 minus 9 is negative 2 1/2. Done. So we're just manipulating it, but you have to make sure if you don't have an equal sign, you kind of keep it balanced. But now I think we're going to get into an equal sign, I think. Can I move forward? Okay. So we'll now use completing the square to help us solve. And I think it's easier to solve by completing the square because you're not doing fictitious things. So I'm going to make a space, my very first move. Is that okay? That sign's going to match here. Half of that is 2. So 2 squared is 4. If I add 4, I'm going to add 4 to that side. Yeah, but you subtracted last time. Yeah, but I didn't have an equal sign, so I had to kind of keep it together. So now I can move it over. So this here, this right here, if I were to take x minus 2 times x minus 2 and FOIL it out, I'd get x squared minus 4x plus 4. Okay, but now I'm kind of stuck with this 5, and I have this 4 over there. So now I want to try and start solving it for x. So I'm going to move this 5 over by adding it. Add 5 to both sides so I get to 9. How do I undo a quantity squared? How do I undo a quantity squared? You're going to do the square root? And if I square root both sides, what do I have to remember to have? Right here. I need a plus minus. So then that gives me x minus 2. Where did the square thing go? Well, I took the square root and that undid it. Equals plus or minus. What's the square to 9? 3. So then I'm just going to add 2, and I'm going to go 2 plus or minus 3. So 2 plus 3 is how much? 5. And 2 minus 3 is how much? -1. So you get 5 and -1 for your answers. Yeah?
Don't you have to subtract the 4? Because it's positive.
So the difference between here and the last ones we did, I didn't have an equal sign. So you're absolutely right. I had to add and subtract from the same side. But because I have an equal sign, now if I add to one side, I can add to the other side. I totally could go minus, put the minus right there, -4 right here. Totally. That's a good catch. But because there's an equal sign, because you have two sides of the equal to keep it balanced, if I do add to this side, I add to this side, perfect. If I don't have an equal sign, I have to add and subtract it from the same side. Okay. I think we can walk through this. Let's go slow. Yeah, I don't know who drew it. It's pretty good.
3x.
So what about the 3x squared? What do you want? What do you want 3x squared to be?
I was just saying, like, space it.
What? Not before I space it though.
Divided over 5.
Divide it all by 3. If I do that, that makes it x squared, right?
Yeah.
All right. So I'm going to divide everything by 3. I'm just doing this. This is all I'm doing. Okay? So that gives me x squared plus 6 over 3 is 2. Now I'm going to make the space as well. Hey, what's 0 divided by 3?
3.
0. Is that okay so far?
200.
Half of 2?
1.
1. So half of 2 is 1. So I'm going to bring this down. So I get x plus 1. Remember that sign has to be the same. 1 squared is what? 1. If I add 1, I add 1 over here because it's on both sides of the equal sign. So I get this minus 5 over 3 is equal to 1. Let me just pause there. Make sure you feel good about it. Does that seem okay? Anyone stuck? Where, I want to get x by itself, so what would be the next step?
Add 5.
Add 5/3? I like that. Add 5/3 to both sides. So I'm going to get x plus 1 squared equals 1 plus 5/3. That's going to give me, I think, 8/3. Do you agree with that? Because I can make that 3/3. So now I'm going to get x plus 1 quantity squared is equal to 8/3. What do you think? How do I undo a quantity squared? Square root. Okay. So I'm going to do square root and square root. Don't forget the plus minus. Is that okay? That's going to give me x plus 1 equals plus or minus the square root of 8/3. Subtract 1. Now, what am I not allowed to have on this problem? Negative where? Or not negative? Has to do with the radical. What can't have a radical? So we have to recognize 8/3 is the same as this. I can't have a radical in the denominator, so I'm going to multiply top and bottom by root 3, which gives me root 24 over root 9, which is root 24 over 3. Can I break root 24 down in a perfect square? What perfect square goes into 24? 4. What's the square root of 4?
2.
So I get 2 square root 6/3. So I'm going to replace this with this. This is just nasty. This, I don't know why we put it like this so bad on it, but nice thing is it does come out to a nice exact value. Notice I didn't do the square root of 6 on the calculator. I just left it.
Is it 24/3, root 24/3 square root of 8?
Because square root of 24 is inside, the 3 is outside. So I can't reduce outside of a square root side to inside. I can go outside to outside, or I can go inside to inside, but I can't go inside of, no. I think some people talk about it like as a jailbreak. You can do a jailbreak and you have your buddy. So you both have to either be inside or both be outside. One can't be inside and one can't be outside. Just break you out of jail. I don't understand the analogy all that much because I've been in jail like in 3 or 4 years. So. That's more like 2 years. All right, let's move on. Okay, quadratic equation. So we're just mainly doing this so you can see how it's going to work in all the ways. Let's see if I can make this work. I'm going to do x squared minus x minus 20 equals 0. I made a space. Oops. So I'm going to go half of 1 is half squared. Half squared is half times half, which is a fourth. Add a fourth, add a fourth. So this is my complete square. I get minus 20 equals 0 plus a fourth is that. I'm going to add 20 to both sides. 20 is the same thing as 80/4. Is that okay? right? I get x minus half squared. That's going to give me 81 over 4. Oh, this will work out actually nicely. Square root, so plus or minus. So x minus half equals plus or minus. Square root of 81 is 9. Square root of 4 is 2. Add half. 1 plus 9 is 10. 10 divided by 2 is 5. 1 minus 9 is negative 8. Negative 8 over that 2 is negative 4. So I get two answers of that and that. So we completed the square to get those solutions. So let's see if we can go through the next step. What does the next column say to do? Ooh, hang on. Correct. Oh, yeah. Ready for the shoulders? Oh. I feel much better. All right. So 5 and negative 4 here. Okay. So what happens if we use the quadratic formula? Well, the quadratic formula, we have to remember x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know that my a value is 1, and my b value is negative 1, and my c value is negative 20. So I get x equals negative 1 plus or minus negative 1 squared minus 4a times c all over 2a. Is that okay? I know we've just done that. Agree? Do a little math. Negative 1 is 1 plus or minus 1. Negative 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 20 is positive 80. All over 2. So I get 1 plus or minus square root 81, which is 1 plus or minus 9 over 2. Is this the same as this? I sure hope so. So I get an answer of 1 plus 9 is 5. 1 minus 9 is negative 8 over 2, which is negative 4. So the quadratic formula and completed square obviously gives the same answer. Why do we complete the square? It's the more accepted way. It's used a lot more often in the science community than the math community. And then if you wanted to go through the factoring, this would actually be the fastest way, saying, oh, I realize that x minus 5 and x plus 4 are factored, so I get x equals 5, x equals negative 4. Which way looks faster? Well, sometimes factoring is going to work much better for you. That's it? I'm done? You're kidding. No lies? All right. What should we do? Homework. So you guys got quite a bit of time, so let's get a good start on this. Let's see. It's somewhere back here. 3 forms? No. No. All right, so page 127, 128. I think we skipped a few pages in there, so please note that. And the nice thing is page 128 is a blank page, so you just have page 127 to do. And you got plenty of time to start on it. Cool? Get busy on it. Ask me if you need help, if you don't mind.